Hello everyone. So in this recording today, I will explain chapter 6 in the book, which is alternative structure. So if you remember, in the first semester we have explored the rhombus. So in rhombus here we put a condition. So a condition, it can return true or false, yes or no, 0 or 1. So probably you have taken something like this: yes, no, true or false. And if it's true, you do some stuff here. If false, you do some stuff here, and then you meet somewhere and you continue the code. So today we'll explore this stuff. How can we formulate the condition? How can we write a condition, or how can we define the positive part and the negative part? So this is it. This is the purpose of this course. However, as we have seen earlier in the previous chapters, that any expression in C provides a numerical result. So everything in C, it has a result, either 0 or non-zero. And we know also that in C, everything that returns 0, it means it's a false, and everything which is not 0, it means it's a true. And every expression returns a numerical value, so we can use any expression in the condition here. So since any expression can return 0 or non-zero, so we can see it, we can consider it as a condition, since 0 means false and everything else means no. So for this we need to see, because later on we will use the word block of instruction. So what does it mean, a block of instruction? We have seen that whenever we have an expression and when we end it with a semicolon, so I have an expression here, if I end it with semicolon, it becomes an instruction. A block, an instruction, it means a sequence of instructions. So we have multiple sequence here of instructions. So in order to say it's a block and instruction, for example, we can place those instructions in the curly braces. So what are the valid block of instructions? So if you have just a block that enclosed with two curly braces and contains 0 instructions, so it's a valid block of instruction. If we have 0 or more, so if we have one instruction, is okay. Here we have one instruction but one empty instruction. So this form, it means I have one instruction but the expression is empty. It's a valid block of instruction. This one is not valid. Why? Just look a bit, and can you guess why? It's easy, because this one is an instruction, however this one is an expression. It should end with a semicolon. So for that, it's not a valid block of instruction. So the rhombus that we have explored earlier, so we call it if here. So so the expression is here, the expression that should return 0 or 1. Inside the if, this is the positive part, this is the block 1 that we place here, and else, it means no, this is the block 2. So how can we write the if else in C? So this is in algorithmics. How can we write it in C? So we write if expression, so we put this inside the if, and then the positive part I will place it here, either in between curly braces, or if it's one instruction I can remove the curly braces, and then I put else, and again curly braces and a set of instruction. So the instruction should return 0 or non-zero. 0, it means false, and non-zero equal to true. So if the expression returns a value not equal to 0, it means true. The block of instruction 1 will be executed. Otherwise, if the expression returns 0, it means that the expression is false, so the block 2 will be executed. So again, a block of instruction could be like this one. So we have curly braces and 0 or multiple instruction, or if it's one instruction, I can remove the curly braces and just write the one instruction. So let's take examples and see different conditions and the usage of the curly braces. So here is an example. We have a program. The program here we initialize, we define, we don't initialize here. So we just define three variables, a, b, and max, and then we print on the screen, enter two numbers. and then the user should enter. So we have here percentage %d. What does it mean? I will give you 1, 2, 3, 4, 5 seconds, and yes, it's an integer. So the user should enter two integers, which are a and b. So, and then we use if, we use the numbers. So we check a is greater than b. So every expression in C returns a number. So example, let's say that the user enters in A 5 and in B 4. A greater than B returns 0 or 1. So A is greater than B, so it will return 1. So 1 is different than 0, so it's different than 0, so it means true. So we will execute the first block. So we will put the value in A in max. So in maximum we'll have the value of 5, and then we'll print on the screen the maximum is 5. Now suppose that we have A equal to 4 and B equal to 5. So again, does A greater than B? No. No, in C it means it returns 0. So 0 is equal to 0. It's not equal anything different than 0. So we will execute the else part, the block 2. So we put 5 in max. So when we will print the maximum is 5. One more example here. Let me erase. So let's say A is equal to 5 and B equal to 5. Does A is strictly greater than B? No, I is not strictly greater than B. So the answer is 0 because it's no. No, it means that we will execute the block 2. So what we will put in max, the value of B. So the maximum is 5. So as you have seen, even if we have the same value, since we have if or else, we have just two answers, whether yes or no. And our program is correct. Let's explore another way to write this condition. So again, we have three variables a, b, and here we have a difference. Again, we print on the screen enter two numbers, and the user should enter two integers a and b. What we will do is that we will calculate the difference between the two numbers, and we will use again an if. We say if diff, so we have an expression. So if diff is equal to 0, we will execute block 2. If it's different than 0, it means that we will execute block 1. Let me erase and let's take the same example as earlier. Let's say A is equal to 5 and B equal to 4. So the user enters 5 and 4. 5 goes into A and 4 goes into B. So in diff, we will have A minus B. So we will have 1. Does 1 is equal to 0 or not? So it's not equal to 0. It means that it's equal to 1 here. So it's true. So we will execute the block 1. So we will write on the screen A is not equal to B, which is obvious. Now let's say A equal to 4 and B equal to 5. And then we will calculate the difference. So the difference would be equal to minus 1. So minus 1 is different than 0. It means that I will execute the first block, and I will write on the screen A is not equal to B. One more example. Let me erase. A equal to 5 and B equal to 5. So in diff, I will have 0. So 0 is equal to 0. So obviously I will execute block 2 and I will say A is equal to B, which is obvious. So we have explored earlier, so I can use an expression here. So here the answer is 0 or 1, yes or no. Here the answers are all the natural numbers. It could be 0, it could be a negative number, or it could be a positive number. Let us explore again a third example. So here an example, here we just use two variables a and b. So the user again enters two numbers, and then we have the condition here. So let's see how it will work here. I have a minus b, just a minus b. So a minus b is an expression. The expression returns value. If the value is 0, I will execute block 2, the else part, and if the answer of the expression is not 0, I will execute the first part. So a minus b, what it gives this in our example. So 5 minus 4, it equals to 1. 1 is not equal to 0, so I will execute the block 1. What if a equal to 4 and b equal to 5? A minus b is equal to minus 1, so it's not equal to 0. Again, I will execute the block 1. Let me erase and take the example of 5, 5. So a equal to 5 and b equal to 5. So a minus b is equal to 0. So 0, it means I will execute the second block, and on the screen we will see a is not equal to b. So we have explored different ways of writing a condition, just to say that whenever we have a condition, it returns either 0 or non-zero. 0, it means false, and I will execute block number 2. Everything else than 0, it means it's 1, it's true, and I will execute the first block. So here we have a first example. Here we are using the curly braces. Since we have multiple instructions, we have 3 instructions, I cannot use just one, I cannot write it without the curly braces. So if we go back, we have here just one instruction, so we didn't use any curly braces. You can use curly braces if you want for more clarity. This is advisable. We will see it later on. So let me erase this here and see what we are having here. So we're trying to swap as it looks. So we are having here 3 variables a, b, c, and we have an auxiliary variable. The user will enter 3 variables, the a, b, and c. And then if a is greater than b, he will try to swap, to change the value of a and c. Otherwise, if a is not greater than b, he will try to swap b and c. So for swapping, I think I have already solved this exercise. As a reminder, whenever I need to swap 2 variables, I need to use an auxiliary variable and in order to do the swapping. So let's take an example. Let's say that a is equal to 10, b is equal to 7, and c is equal to 5. So we reach here, we check if a is greater than b. A is greater than b, yes. What does it mean, yes? It means that I need to execute this one. So in auxiliary, I will put a, I put the value of 10. In a, I will put the value of c, which is equal to 5. So 5 will came here. And in c, I will put the value of the auxiliary, which is equal to 10. So at the end here, so this one will go, this one will go. I will have a equal to 5, b equal to 7, and c equal to 10. So I have ordered somehow the value. So let's take an example where we execute the second part. So let's take it's the eraser here. So let's take a is equal to 5, b is equal to 10, and c is equal to 0. So we are here. Does a is greater than b? No. So I will execute the block 2. So in auxiliary, I will put the value of b, which is equal to 10 here for now. In b, I will put the value of c. So the last value of c is equal to 0, and in c, I will put the value of 10. So at the end, at the end we have a equal to 5, b equal to 0, and c equal to 10. So this is it. So the purpose of this exercise is just to say that if we have multiple instructions, so make sure to place 2 curly braces, one open curly braces before the instruction and one before the else part. So we have seen the instruction if else. However, in some cases we don't need the else. So again, in the first semester, when we had a condition here, for example, there were examples where we had some instruction here, and then we have math and continue the code here. So in some cases, I don't care about the else part. So I just want to work in the cases where there's a positive part. For example, we can write a program to say that if you got a grade over 80, you will get +1. So I don't care about those who didn't get a grade less than 80. I will do nothing. So I just want to give one point as a push for those who got 80 and above. So those who didn't get 80 and above, I don't care about them. I will not give him anything. I don't have to treat their cases. So we have something like this. So it depends on the question. So you should be aware that since the else part is optional, so usually when we have multiple if and else, it leads to confusion, and we will see an example on this in a while. So, and as a rule, whenever we see an else and there is no curly braces, when we see an else and there is no curly braces, we link it to the last if we have it. So if we don't want to have a confusion, so make sure to use braces. So let's see an example. So here we have the same instruction. We have if n greater than 0, if a greater than b, max equal to a and max equal to b. So here we are not using curly braces. Here we are using curly braces. As we have said, whenever we don't have curly braces and whenever I see an else, I will link it to the last if encountered. So here the else is linked to this one. However, if I'm using curly braces, I'm specifying that this if does not have an else, and however this else is linked to this if. So in order to not do mistakes, so we advise you to use curly braces and to indent. What does it mean to indent? Is to use the tab button that you see it on your keyboard on the left. Tab, it means that it pushes the sentence 7 spaces. So whenever you are using if and later on a switch and in the next chapter for while, do while, make sure the body, we call it body here, to tab it, to use tab. And again, so it's recursively, it means that if there is if inside if there is if inside switch and stuff like that, make sure every time to indent. So let's consider the following sequence of instructions. We have this multiple instruction, we have if else. It's not indented. It's very difficult to understand what's happening here. So they are asking us, please rewrite the sequence of instruction using tabs to mark the if else blocks belonging. So we need to use if else because like this, if we now in the next slide we need to execute all this example, it will be very difficult for us to know what the output will be. So let's work it together. So we have here an if. I will write it above. So if a is greater than b, I will print f first choice. So let me just I will write it like this because there's no places, so it's okay. And then I have an else. So since we don't have curly braces, we link the else with the last if encountered. So the last if encountered is this one, so we link this one to the else part to this if. Then in the else I have if. So look well, I have indented here and now I'm indenting for the if. So in if I have if a greater than 10. So I will indent one more time. So here we have 2 indentation. I will say printf. So most compiler they do it by their own. So but you should know how to write it. So here's second choice. And we end it here. There's nothing else. There's no curly braces, so it ends here. So next, I have a new instruction. So it's at the same level here. I will write if b less than 10. I will indent printf third choice. And then I have an else. So else is linked to the last if encountered. Indent printf fourth choice and semicolon. So again, so let me repeat, I have an if, I have an else. So else is linked to the last if. Inside the else I have the if instruction. So the if else is considered as one instruction. So this one is a one instruction and I have put it inside the else. So pay attention to the fact, I repeat, that if and the positive part is an instruction, is considered as one instruction, and all this one is considered as one instruction. So here there is no need to use curly braces. However, for clarity, you can use a curly braces. If you omit it, it's okay, because in C, the if instruction is considered as a one instruction, the if else instruction, and with everything here, if you have even multiple instruction here, it's considered as one instruction. I will give you an example later on this one. So I want to just, if I can erase some of these writings. And let us execute the program. So this is it. I will remove all the unnecessary explanation just to make it clear, and let's start. So they are asking us to I have the eraser here, I want it back. So they are asking us to determine the program response for each of the following pairs of numbers. So suppose that the user enters A in 10 and 5 in B. So what should be printed on the screen? So let's think together. Does A, so if does A greater than B, so you will say yes. Yes, I will execute the first printf. So on the screen I will print first choice, and then I will go to the line because we have \n. So I don't execute the else part here. I will not execute it. Then I will move down. Does B is less than 10? Yes. So I will print the first printf here. So it means I will print third choice, and I will go to the line because we have \n. So next one, A equal to 5 and B equal to 5. So does A greater than B? You will say no. So I will execute the else part. In else I have a new instruction. Does A greater than 10? You will say no. There is no else here. There is nothing to do. I will pass to this part, the lower part. So does B is less than 10? Yes, it's equal to 5. So I will print this part, this block, the first block in this instruction. So I will print, third choice, and I will go to the line. A equal to 5, B equal to 10. Again, does A greater than B? No. I will execute the else. In else I have also an if. A is greater than 10. No. So there is no else here. There is no else here. So I have finished this instruction. Let's move to the second instruction. B is less than 10. No, it's not less than 10. So I will execute the block 2. So I will print on the screen fourth choice. Again, A equal to 10 and B equal to 10. Is A greater than B? No. I will move to the else part. A is greater than 10. No. And there is no else part here. There is no else. There is nothing to execute. I will move down. Does B is less than 10? No. I will print the block 2. So again, I will print fourth choice. Now, A equal to 20 and B equal to 10. A is greater than B? Yes. So I will not execute the else part. So this is all the else part. I will not do anything in the else part. So I will print first choice. I have finished the first instruction. I will move into the second one, which is here. B is less than 10. No. So I will use and there's else. So I will print the block number 2, which is here, fourth choice. And lastly, A equal to 20, B equal to 20. A is greater than B, obviously is no. I will go to else. In else there's another condition, another expression. A is greater than 10. Yes, A is equal to 20 is greater than 10. So I will execute the positive part. So I will write here second choice, and I will move to the lower instruction. B is less than 10. No. 20 is not less than 10. I will execute the negative part, which means fourth choice. So this is it for this exercise. So it's very instructive here, because we have seen that we have in this code 2 instructions, 1 instruction here, 1 instruction here. We have in the else here another instruction, which is the if. So make sure to review this exercise, to rewrite it, maybe place it inside a main function with to scanf for A and the B, and maybe see the output on the screen. So the next part, so we have explored if and else, and then we have explored if without else. In the third part, we can have multiple if inside each others. So we have if and a condition here, which is an expression. So if it returns a non-zero number, we will execute the block 1. Else we have a new condition, we will evaluate expression 2. So and so on. So let me go back. So this is what we have explored here, in fact, but we didn't say it. So I have if else, and inside the else I have another condition, which is if. So we have multiple if inside each other. So whenever we find an expression that is not equal to 0, I will execute the block 2 and I will jump to the outside of the last else. So whenever one of the expression is true, I will execute its block and the condition finishes. So if you look well, the last one here, the last else, so if all the expression returns false, returns 0, at the end I will execute the last block. So let's have an example. So we have here again two variables A and B of type integer. The user will enter the values for these numbers A and B, and then we have multiple if and else's. So we check first, does A is greater than B, and we will print okay, A is greater than B. Otherwise we will check, does A is less than B, we'll say that A is smaller. Else it means that A is equal to B, and then I will print A is equal to B. So let's take an example, A equal to 5, B equal to 4. So does A is greater than B? Yes. So I will execute this part. So I will print on the screen 5 is greater than 4. What if A is equal to 4 and B equal to 5? So obviously A is not greater than B. I will not execute the positive part. I will move to the else. In else there's another if. So I will check. A is less than B? Yes. It means that it's not 0. So I will execute this part on the screen. I will see 4 is smaller than I. So what if A is equal to 5 and B is equal to 5? So A is not greater than B. I will move to the else. In else I have a new instruction, which is if and else. So A does it less than B? So obviously no. So at the end I don't have any more conditions. I will display on the screen that 5 is equal to 5. So by practice you will learn more about using this stuff. And again, here you could have not just one instruction. So if you have multiple instructions, you can use curly braces and put the set of instructions in between the curly braces. So why it's very useful to use the if and else, the multiple if and else. Let's say that especially the last else, why we use it a lot. So let's say, for example, the user should enter Y or no, and for example you want to ask him something, and at the end you want an answer. So if it answers yes, it will print, he will enter Y, and if he wants to answer no, he will answer with N. So we need to check. If he enters Y, you do your job. If he enters no, you will tell him bye bye, or again there's another things to do. You can have again multiple instruction inside curly braces. So else it means that he enters a character which is not Y and N. So of course you will tell him there's a beep here because \A, and you will tell him there is error. So please pay attention. So for that it's very important whenever we are using a multiple if and else to pay attention to the last else, because in case everything fails here, at the end the else part will be executed. So later on we will see more about this when using the switch instruction. It's a modified version of if. So let's have another exercise here. So the exercise here is on page 64 in the book. So it's exercise 6.2. So we have again if and else's. They are not well tabulated. So again they're asking us to rewrite. the sequence of instruction using tabulator in order to mark the if and else. And in part 2, they are asking us, give us the values of A and B. So to have, for example, first choice, second choice, third choice, and fourth choice on the screen. And they are telling us for which values of A and B we do not get an answer on the screen. So first let's us rewrite it, and then we will tackle the following question. So let me see if I have a place here. No place here, so I will try to answer it here. So just a second, let me move this one here in order to find some place. So we're still recording, I don't care about this, and let's move. So we have if A greater than B, and then I have an if. So if is an instruction, so I'll make a tab and if, because an if cannot have empty block. So if A greater than 10, I have printf. So I'm not using curly braces. It means that it's inside the if. So printf first choice. I will keep just first here, just to minimize the writings. And then I have else. So else, it's linked to the last if. So it's linked to this one. In else, I have an if. So if is inside else. So else, and tab. So if B less than 10, I will print f second. And then I have an else. So else is linked to the last if. Same level as this one. So here we have 3 tabulation, here we have 2. In else I have also an if. It's very tricky here to write it. I should have written it normally. So else, let's try our best. If, so it's inside the else. So if A is equal, so it's the equality test, I will print. So inside if, so here we have 4 tabulation, print f, I will just write PR, sorry, but there's no place, third. And then I have else. So else is linked to the last if encountered. So again, 1, 2, 3, 4, not 4, 3. So else, because it's linked to the last if, print f fourth. You can write it like this, or you can write it like this one, using if else. I prefer to write it like this in order to see the blocks, the indentation, and it's more visible and it's more easier to solve this problem. So let's move to the second part. Give me values of A and B in order to print first choice. So if I want to execute this instruction, I want to see first choice on the screen. It means A should be greater than B and A should be greater than 10. So it's easy. In order to see first choice, A should be greater than B. So first choice, A greater than B and A greater than 10. Let's write it here, and so I'll erase and write it more clearly. Where is the eraser? So so in order to have first choice, I'll write it here. So A should be greater than B. So if A greater than B, I will do the positive part. And if I want the printf first to be executed, it means and A should be greater than 10. For example, you can take 12 for A and B equal to 6. So anything that verifies this condition, these two conditions, it will be true. So let's move to the second choice. What does it mean, second choice? So second choice is here. Second choice is in the else part of the second if, but it's inside the positive part of the if. So obviously A should be greater than B in order to execute the positive part of the if. However, the second printf is in the else part of this one. So to be in this one, it means that this condition should be false. In order this one should be false, what's the negation of A greater than 10, it means A should be less or equal to 10. So whenever A is less or equal to 10, I will be in else, and let's see, in order to print f second, B should be less than 10, and B should be less than 10. So this one is not necessarily, because we have A is less or equal to 10 and B is less than A. So B is less than A and A is less or equal to 10, and we have B is less than 10. So at the end we will have here B is less than A and A is less or equal to 10. So if this is correct, we can print on the screen second choice. Let's see for the third choice. How can we print third choice? What are the values for the third choice? So in order to print a third choice, so let's write it here, third choice. So first, A should be greater than B, because I need to be in the positive part of the if. I need to be in the else part of the second if. So A should be, so the negation of A greater than 10, so A should be less or equal to 10. I will write it directly here. So A should be less or equal to 10. So we are here now, we are in the else. I want to print third, so B should be greater or equal to 10. We are here, and so we are in the else part, and again A should be equal to B. A should be equal to B. So how it could be 10 is, because here we have equality and here we have inequality, how it could be that 10 is greater than 10? So it's impossible. And we have A is greater than B and A is equal to B. So we have here a contradiction, and in fact there is no values for A and B, for which we can see on the screen third choice. So the person who wrote this program, he's not a good programmer, because he was writing if and else, and there is no value, there's a lot of contradictions, and there is no values for A and B for which we can reach this instruction. This block will never be executed, never, ever. So let's see about the fourth choice here. So we have seen that never ever we will write third choice. Let's see about the fourth. So the fourth, again, we have, I write it here, A greater than B. Then I need to be in the else part, so A is less and or equal to 10. Again, I need to be in the else part here, so B should be again greater or equal to 10, and A should be here A different than B. So again we have a contradiction, because of here, how 10 could be greater than 10. So again it's impossible, and the fourth choice, it will never be printed on the screen. So this is not the person who wrote this program is not a good program, and it's very easy for you, because you're new programmers, to write codes like this. So you should make sure that every block can be reached, it's reachable somehow. So they are telling us for which values of A and B do we not get an answer on the screen. So we have already seen that we don't get answer for the third choice and the fourth choice. So we don't have answer for values if A is less or equal to B. So whenever we have A is less or equal to B, we will not have any answer on the screen. So this is it for this exercise. Make sure to repeat it, maybe to tap it on the compiler, and try with different values of A and B, and to check that when we get an answer, when we do not get an answer, and try to avoid these kind of programming. So let's move to a more subject here. It's about conditional operators. We have special operators in C. We have seen special operators especially for C, like the plus plus, minus minus, the plus equal, minus equal, and again we have control operators, which is the question mark and the colon. So this operator, it's very special because it uses two symbols, the question mark and the colon, and it's the same as if. So here it's equivalent to if expression 1. So if expression 1 is true, I will evaluate expression 2, otherwise I will evaluate expression 3. So let's see an example. So if you have here the if and else, the calculation of the maximum. So if A is greater than B, I will put the value of A in max, otherwise I will put the value of B in maximum. So this is the same like this one. So the condition, I will put it here and then the question mark. The positive part will be A and the negative part will be B. So what does it mean this? So if A is greater than B, I will put the value of A in max, otherwise I will put the value of B in max. So you can use this instruction, however, please do not use it like this here. So for example, when you can embed it in other instructions, it will be difficult to understand. So as a beginners in programming, please refrain from using it a lot. So because it will be difficult for you to debug your code in case there's an error. So for example, here there's a printf. In printf we have two percentages. It means that we have two variables or two expression on the right after the semicolon. So we have n here. So I would be replaced by n, and c, a character, would be replaced by the value of the conditional expression. So if n equal to 1, on the screen it will be printed you have one book. So there's here one space. Otherwise, if n is not equal to 1, greater than 1, I will put s. So for example, if n is equal to 10, on the screen we will have you have 10 books. However, if you have n equal to 1, we will have you have one book and space, and this is it. So again, you should make sure that whenever we are using conditional expression, and what we have seen in the previous chapter about the type conversions, the automatic conversion, the casting, so it applies here. So for example, here we have an integer and f is float, so the result would be of type float even if the f wasn't executed. So here an example, we say that if n is greater than 0, I will use the value of n, otherwise I will use the value of f. So even if I will use the value of n, it will be converted to f, which is of type float. So again, make sure to take into account when using conditional operators this stuff. So it's very elegant to use it, but you should be very strong in using this operator because it's very prone to mistakes. So let's move to switch. So switch in the book is at page 64. I have skipped the break and continue on page 62 and 63 because I will explain it in a while. I will explain break. As continue, I will keep it for the next chapter since we will not use it in this chapter. So the conditional operators already is in page 66. I have changed a bit the order because the switch is very interesting, and there's break, there's continue and stuff like that. So let's see an example first and then see the formal definition of a switch. So we have here in a program, we have one variable of type integer and the user will enter n. We have here a set of examples of execution, and we will see the example and then we will understand the code. So the user will enter 0, n equal to 0. So we will arrive here. So n is equal to 0. The program will check a case where it's equal to 0. So line by line, he will check the code line by line. He will arrive here. So case equal to 0. So n is equal to 0 and the case here is equal to 0. He will execute null. So on the screen we will say null, and we have a break. What does it mean, a break? It's not a KitKat. So break, it means that I need to cut the code. It means switch finished and I will move to here, to the outside of the switch. Whenever I see a break, I'm get out from the block of instruction. We will use it again in the next chapter whenever we are looping, we are doing a continuous job. So whenever I see a break, it means, okay, I need to take a break. So let's stop this and what I'm doing now. So if I have a switch, I have a break, I'll stop. Okay, I have finished, I have found my values, thank you. And I will write bye. Let's see one here. I'll erase because there's a lot of arrows. So 1, I'll switch to 1. So in n I have 1. I will check 0 is equal to 1. No. 1 is equal to 1. Yes. I will print 1. I have a break. Break. Give me a break. Out. There's a bye here. I will print bye and finish. Let me erase. Let's take example 2. Here n is equal to 2, so switch 2. I will find a case where it's equal to 2. Case 0 equal to 2, no. Case 1 equal to 2, no. Case 2 equal to, yes. Print F2. There's no break here. I continue. I print 3. I print big. The switch finishes. I print bye. So break is very important because I will stop. So if you can see, it's like an if else. So if n equal to 0, I will do this. If n equal to 1, I will do this. If n equal to 2, I will do all this. If n equal to 3, I will do all this because there is no break. So for n equal to 3, I will check. Case 0 equal to 3, no. Case 1 equal to 3, no. Case 2 equal to 3, no. Case 3 equal to 3, yes. I will print 3, I will print big, and I will print bye. Last example 5, let me erase. So again, in n we have 5. 0 equal to 5, no, 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 no. Default, it means whenever I don't find it, there's no case. So it's default, it's for everyone. It's like the else that we have seen, the last else in the multiple if and else's. So I will print big, and then I will print a bye. Let's take another example. So it's for you now to tell me what's the output. So I will try to talk a lot now, just to make you to let you think about the answer, and maybe you find it. So they are telling us, give us the output for n equal to 1. So the user will enter 1, and then we have a switch which is equal to 1. So I need to check if there's a case equal to 1. I'll start from case equal to 0. So I don't jump directly, even if I can see. The computer can't see there's a case 1. You need to check line by line. So case 0, 0 is not equal to 1. Case 1, oh, amazing, it's equal to 1. I look here, there's nothing. What should I do? There's a break here, there's no break. So I continue. So what should I print on the screen? I will print small, average, and after average there's a break. You know, there's a break. So I print small and average. Let us see. Amazing, I nailed it. Small and average. 4. So what about 4? So the user enter 4. Switch 4. 0, no. 1, no. 2, no. 3, no. 4, yes. There's nothing here. Again, I'll print average, and I have a break. So on the screen we'll see just average. 25. No, there's no animation here. So 25, there's no 25 here. So we'll arrive to default, and we'll print big, and this is it. So more technically, how can we define a switch? So in switch we have an expression here, and then we have the keyword cases. Here we have constants. It could be an integer constant or a character constant, but we cannot have a float constant. So we cannot have a commas in the constant. We cannot have case 3.2, case 1. We can have case A, case with a constant in between a single quotation. We can have case 1, number, integer, but we cannot have floats. It's forbidden. So inside this we have blocks. So everything between brackets, it's optional. So as we have seen here, it could be there's no code. It's normal, no instructions. And even the default part, the last one, it could be also the optional. So again here the expression, so it could be of type char or integer, but as you have written here, not of rational type. We cannot have a rational number. So here we are giving you an example about characters. So we have a char choice. We have here an expression. This expression is a choice equal get char. Get char, it means the user should enter a value and it will be in choice. So if the user enter small r or capital R, on the screen we will see red, and then we will get out of the switch. If it enters B or B, it means blue. G, it means green. So it's stuff like that. So we have already talked about this. We have already seen break. So break, it terminates a loop or exit a switch. So the loop, we'll see it in the next chapter. For example, for while, do while. So we will be interested for now for just the switch. So when we have a switch, we get out from the switch. A break, it's called break. So we need to take a break. So we have ended the course. So the exercise, I will solve each exercise from the book, and also for this time I will make a recording for each of the additional exercises and for the exam. So on the website, exam questions are not included in the assignment exercise, but you can find it directly in the exam links. So on the website, let's go on the website. So on the website, so this is the website. In the assignments, you will not find it. You will find it in the exam. So in the exam, you have partial here, midterm, and you can find the questions and the solutions, and they are not included in the links in the exercise here. So I will add a video so that you can watch me solve this exercise. So this is done for this chapter. If you have any questions, do not hesitate to send an email for me and I will try to answer you. Again, do not forget to subscribe to my channel and to hit the bell icon to receive all notifications. And thanks for watching and stay safe.